Hi, class. This is Dr. Lindner. Welcome. What we're going to be covering in this next session is an overview of the neural system. Now, I always start with this silly picture of Homer Simpson here because, when people look at the picture, they go, all right, very, very small brain. He must not be very intelligent. Maybe that's true in the cartoon, but the reality is, if you think of computers the way they were 30, 40 years ago, they were massive. They were huge. They were put in these rooms that had air conditioning units, fans, and filters to cool them off. I mean, massive. They were huge. And over the years, if you think of what's been happening, is they've been getting smaller and smaller and smaller, faster and faster and faster. Back then, they were bigger and they were slower. Now they're smaller and they're getting much, much faster. And that is true about the brain, is that even the smallest parts of the brain, like this part here, which we'll learn about, the cerebellum, is much quicker and faster and does a lot more work than all of this stuff combined. Okay. So what's interesting about the neural system, and I like to use the word neural, not nervous. I don't like anyone to be nervous. So when I say the word neural system, it implies what your textbooks talk about as the nervous system. I just have never been a big fan of the word nervous. So the neural system develops at around day 18, when sperm and egg come together and there's fertilization and then implantation on the uterus. At around day 18, embryologically, the very, very first system that develops is what we're looking at here, the neural system. And from that, all other systems blossom and develop, because the neural system controls and coordinates all the functions of the human body in conjunction with the endocrine system, of course, but this one develops first. It's just not called the neural system. There's something, I believe, embryologically that was called the primitive streak, and then the primitive streak becomes what's called the notochord. And you see the word cord, like spinal cord. And the notochord develops into this. When we teach A&P, neurology and A&P, we break down the neurology into two main systems: a central neural system, CNS, central neural system, and a PNS, which stands for peripheral neural system. So what you see here in the center, which is just the brain and the spinal cord, that alone is the central neural system. Everything outside of that, whether they are nerves that come off the brain, like cranial nerves, or the nerves that come off the spine that are spinal nerves, or little ganglia, which are a group of nerve cell bodies outside of the CNS. These, and even your receptors, when you touch something and it's hot or cold or sharp, these are all parts of the peripheral neural system. And what ends up happening is, let's say you touch something and it's hot, right? This information goes like this. It goes up into the brain, right? That's how you can perceive that you just burned your finger. So the information that's going upward is what we call sensory information. And it ascends, meaning it's going up. And that sensory information is also referred to as afferent information. Afferent is the same thing as sensory, and it ascends, meaning it goes up. After the brain processes the information, that information that starts in the brain that goes down the spinal cord out to your muscles to make them move, those are motor information. Motor information descends. meaning it goes down. And it's not afferent information, but it is efferent information. Afferent. So sensory goes in and up, motor goes down and out. Sensory is afferent information, motor is efferent information. Those are some of the basics. Okay. The spinal cord goes from around right under the base of the occiput, and where that magnum foramen is, that big hole in the bottom of the skull, the magnum foramen. And then the spinal cord comes down, not all the way to the bottom. It stops somewhere around here, somewhere around the L1, L2 interspace. That's the length of the spinal cord. So inferior to L2, like from L3, L4, and L5, that's not spinal cord. Those are just nerve fibers at that point. Okay. And that's where many times needle injection can go in down here, like a puncture to pull out cerebral spinal fluid, or epidurals. They're always done below L2, because if it's done here and the needle penetrates the spinal cord, we got some problems, right? So the central neural system is the brain and the spinal cord. The peripheral neural system is the cranial and the spinal nerves primarily. They both contain sensory and motor fibers, incoming and outgoing messages from the spinal cord. Okay. If I were to draw out a cross section of the spinal cord, like this, a little hole in the middle here, and let's say this is dorsal and this is ventral. This is the back, the posterior, right? If I draw a little imaginary dotted line across here, everything from here back is posterior and everything from here front is ventral. There's information that comes in. There's information that's coming in this way, and that's your afferent or your sensory information. And then the motor information comes out this way, maybe to your skeletal muscle to make it move. So sensory comes in, motor comes out, and there is a relay, or a synapse, if you would, between the sensory and the motor. So you got sensory coming in, motor coming out, but what's the relay man between the two, right? There's a neuron called an interneuron. Inter means between. There's an interneuron between the two. Okay. And this is really what I just drew out is a simple reflex arc. Like literally, if you touch something sharp or hot and your hand pulls away so quickly, you don't even realize it, then your brain perceives the injury or the burn. You have the sensory input of the hot thing that touched your finger coming in. It relays that, processes that information here in the spinal cord, sends out the message through the motor neuron to the muscle, then your finger withdraws. That's a reflex right there. Okay. So these, whether they're sensory or motor nerve fibers, they connect to your muscles, your glands, and all your sensory receptors. So here's a little overview. If we look on top, that's your central neural system. So what does that mean? That's your brain and your spinal cord. Okay. What's coming into it and what's coming out of it? So what's coming into it is sensory information. What's coming out is motor information. That's what I was showing you here. Coming in, coming out. So what's coming in from your somatic senses, soma means your body, your joints, your muscles, Okay, every time you move your arm or you take a step, there's sensory input coming into your neural system from your eyes, from your ears, from your nose, all of your special senses. They're all sending input into the brain and spinal cord, and it's processing that information. Then it's going to send a motor command. Now that we've taken that information, we're going to tell you what to do with it. So now we have motor output. And the motor division has a somatic neural system and it has an autonomic neural system. Somatic neural system is usually abbreviated as SNS, and the autonomic neural system is abbreviated as ANS, autonomic. Now, what does autonomic sound like? It sounds like automatic. It doesn't require conscious thought. And autonomic means self-regulating or self-law. So the autonomic neural system is sending out information, motor information, to your sympathetics and your parasympathetics. These are two different parts or branches of the autonomic neural system. The sympathetics usually speed things up, whereas the parasympathetics usually slows things down. So think of it as like an accelerator and a brake for the most part. There are some exceptions, and I'll tell you what they are. But a sympathetic is going to make your heart race. Like if you've been scared, what happens? Your pupils dilate, your heart races, you're breathing quicker, so you can save your life. That's a sympathetic response. Parasympathetic is what happens when you're eating. You want your heart to slow down. You don't want to be stressed. You want to be in a relaxed state while you're eating food. So that's parasympathetics. Glass of red wine, relaxing music, that's all parasympathetic. So the sympathetic and the parasympathetics are going to the things that you can't control, which is your heart, your glands, and smooth muscle. Skeletal muscle, not, but smooth muscle. Smooth muscle is around your blood vessels, it's around your organs, it's around the uterus. Each month, when your monthly bill comes and your menses come, you feel contractions. You feel those contractions are smooth muscle contracting. When your blood pressure goes up or goes down, the smooth muscle around your blood vessels are contracting or dilating. So that's sympathetic and parasympathetic. Your somatic neural system sends those messages to your skeletal muscle, right? From the somatic senses, the sensory came in and the motor came out to it. This is voluntary, this is conscious. These are involuntary. So let's take a closer look at the sympathetic and the parasympathetic branch, the autonomics. Okay, so the sympathetics, let me change the color here, a little bit different so we can see it better. So the sympathetics, this is known as the thoracolumbar outflow. The reason why it's called the thoracolumbar is look at the levels, T1 to L2, thoracics and lumbars. So it's the thoracolumbar output. It's also what I call the fight or flight response. Fight or flight is someone's coming after me, an animal is going to either chase me, I need to get out of danger's way, or I got to get ready to take it on heads on. Fight or flight. What's going to happen? My pupils dilate so I can see better. My heart pumps lots of blood to my muscles, to my quads, to my biceps, my hamstrings, so I can run, get out of danger's way. I can throw punches if I need to. My pupils so I can see better with more light coming in. That's sympathetic, fight or flight. Parasympathetic has the opposite impact. It's more, this is more of the accelerator. This one's the brake on the cardiovascular system. It slows it down. Slows down my breathing, slows down my heart rate. We call this one, call the parasympathetics, the feed and breathe, or rest and digest, because that's what they do. Feed, breathe, rest, digest, everything that happens during rest and digest has to be common. You can't be fighting and arguing with someone while you're trying to digest your meal. You'll have indigestion. So the parasympathetics is called the craniosacral output. Remember the sympathetic was thoracolumbar because of T1 to L2. Parasympathetic is craniosacral because there's a cranial division involving cranial nerves 3, 7, 9, and 10, and then a sacral output, sacral segment and nerve fibers S2, 3, and 4. Down below, oculomotor is cranial nerve 3, facial is cranial nerve 7, glossopharyngeal is cranial nerve 9, and the vagal nerve is cranial nerve 10. When we talk about cranial nerves, they're always in Roman numeral. So if you don't know Roman numerals, stay on at the end and I'll do a quick review as to how Roman numerals work. You only have to know Roman numerals 1 through 12 anyway for neurology. Now, sympathetic speed things up, parasympathetic slows things down. The exception to that, where everything is backwards, is digestion. When you're in a fight or flight, angry, fighting, running type of physiology, is that the time you want to digest foods and to speed that up? No. In fact, it shuts down digestion. Parasympathetics, when you're calm, that's when it speeds up digestion. That's why when you eat, you don't go out swimming and playing sports. You don't do something like eating, which is a parasympathetic activity, and then do something that's sympathetic. That's why your ma or grandma would say, don't go out swimming so close after you eat. You'll get indigestion, right? Okay, let's take our first break. When we come back, we'll talk about the neuron.